The principle of a vacuum refers to a space entirely devoid of matter, including air, particles, and atoms. It is a concept that plays a crucial role in various fields, including physics, engineering, and astronomy. Here's a detailed explanation. A vacuum is a region of space where the pressure is significantly lower than the atmospheric pressure, meaning it has very little matter or no matter at all. In an ideal vacuum, there would be no particles of any kind, no atoms, molecules, or any other substance. In practice, it's challenging to create or find a perfect vacuum, so vacuums are often classified based on how much matter remains, partial vacuum with some air or gas remaining. Significantly reduced pressure, often used in scientific experiments. Extremely low pressure, used in advanced research and technologies. Theoretical concept with no matter at all, impossible to achieve practically. In a vacuum, the absence of matter means there is no air pressure. If a vacuum is created inside a container, the higher pressure outside will exert a force on the container. This principle is used in various applications, such as suction devices and vacuum pumps. Even in a vacuum, gravity still operates. This means that objects within a vacuum will still fall towards a gravitational source, like Earth. However, without air resistance, they will fall at the same rate regardless of their mass. Space is often considered a near-perfect vacuum because it has extremely low densities of particles, mainly hydrogen and helium atoms. However, it's not a perfect vacuum, as it still contains cosmic dust, solar wind particles, and other matter, albeit in very low concentrations. The vacuum of space is crucial in allowing light and other electromagnetic waves to travel long distances without scattering, which is why we can observe distant stars and galaxies. Even in a perfect vacuum, quantum field theory suggests that it is not entirely empty. The vacuum is filled with fluctuating energy fields that give rise to virtual particles popping in and out of existence. This concept is known as vacuum fluctuations, or quantum vacuum. One consequence of quantum vacuum fluctuations is the Casimir effect, where two uncharged, closely spaced metal plates attract each other due to the altered quantum vacuum between them. Creating and maintaining a vacuum is essential in many scientific and industrial processes. For example, vacuum chambers are used in material science, electron microscopy, and space simulation. Early electronic devices used vacuum tubes, where the absence of air allowed electrons to move freely between electrodes without colliding with gas molecules. Vacuum packaging is a method used to preserve food by removing air from the packaging to reduce the growth of bacteria and oxidation. Achieving a perfect vacuum is impossible because even in the most advanced systems, some molecules or particles will remain. The best vacuums are those that have the least amount of residual gas or matter. Containers or systems that maintain a vacuum must be strong enough to withstand the external atmospheric pressure trying to collapse them. The principle of a vacuum revolves around the concept of an empty space, devoid of matter, where pressure is significantly lower than normal atmospheric pressure. While a perfect vacuum is theoretical, practical vacuums are used in many areas of science and technology. The concept extends to quantum mechanics, where even a vacuum isn't truly empty but filled with fluctuating energy fields. The study and application of vacuums are fundamental in understanding both the macrocosm of space and the microcosm of quantum phenomena.